All right, students, we are wrapping up nomenclature. Not that we're ever going to leave it. We're going to be using it for the rest of the semester, but we're nothing new about nomenclature. Today, we're going to just review nomenclature in a different manner. So we're going to be doing it with some chemical equations, and that really doesn't change the nomenclature at all. It just changes the way it looks a little, okay? So we're going to get working on this, and there we go. Okay, so you have this page and there's some very important information here at the top. Pause the video a moment to read it. But I'm going to do these 5 examples with you, and then you'll be working the rest on your own. And you're never totally on your own because, of course, you can always come by for tutorials and get help. And that would be a very good thing when you need it. We had class time to work on these, but if you're watching this video, you likely missed class, and therefore you want to come in for tutorials to get help with it. It is no longer something you have time for in class. All right. So what we're going to do is we're going to turn words into formulas, formulas into words. That's what we're up to, okay? And so I'm going to get something to write with here. And okay, so I have something to write with. You'll want something erasable because we're going to like crisscross charges and then erase charges thing. So you'll want that. Okay. Before we get started, I want to point out that we have 2 types of nomenclature. We have ionic and we have covalent. And the difference is ionic will start with a metal. So if it starts with a metal, crisscross and reduce. Covalent starts with a non-metal, use prefixes. Okay, very different things. Prefixes does not crisscross reduce, only ionic does. Okay, so 2 very different systems, but it's nice and easy. If it starts with a metal, ionic, crisscross reduce. Starts with a non-metal, covalent, prefixes. No crisscross reduce. Okay, so we're going to move along, and here we have solid tin. And so we look up what tin is on the periodic table. It is Sn. And this tin is by itself. There's no second name with it, so it's just by itself. Now go up to that very important list at the very top of the page and look through those 7. Is tin one of those 7? No, it's actually not. So this is all we do for tin. We just write Sn. Now, it does tell me it's solid, so I'm going to put a little S. And that's just something I want you to start getting used to as we move into chemical reactions next, is that the S stands for solid there. That's all that means, okay? Not really important, just lets you know it's a solid, okay? We're going to have liquid bromine, and bromine is Br. And now I want you to go to that list and check out that list. And yeah, in the list, you probably noticed that Br is in the list, it gets a 2 because it's by itself. There's no second part to the name. That's how you know it's by itself. And it's also a liquid. So I'm going to put a little L there. That is an L. It's supposed to be. I know my handwriting is awesome. Yeah, I know. Okay, so it's going to yield. Now I have tin for bromide. So that definitely, that's a compound because I have the 2 parts of the name. And it starts with a metal. Tin's a metal. So I need charges, and I'm going to crisscross and reduce. So tin is Sn. So what's the 4 tell me? Is it the amount of tin atoms, or is it the amount of charge? Please say amount of charge, because that's what it is. Tin is a +4. Now I've got bromine, Br. And we go to the periodic table. It's in group 7A, which is all a -1 charge. And I'm going to crisscross. Well, I would have a 1 there. I don't normally write 1s, but I can. I would have the 4 there. And now I'm going to erase the charges. Okay, so there we go. And it tells me that the tin is a solid. So I'm going to squeeze a little S in parentheses on the end. There we go. That's all there is to it. So it's just plain old nomenclature we've been doing, all mixed up though. And that's why I'm saying, remember the 2 types. Starts with a non-metal, covalent. It's all about prefixes. Starts with a metal, it's ionic. You do the crisscross and reduce. Okay, so liquid dihydrogen monoxide. Okay, hydrogen. And I hope you even just hear it. The prefix is there. This is covalent. Okay, so we use the prefixes. Hydrogen is dihydrogen. Monoxide, 1 oxygen. And then it told me it was liquid, so I'll put a little L there. And then it says di. Ooh, I have prefixes again. Must be covalent. No crisscross, no, just covalent. Just use the prefixes. Nitrogen is a dinitrogen. Oxide's a trioxide. So there we go. And that was solid. So I'm going to put a little S there. And it yields, and now I've got hydrogen nitrite. Ooh, okay, so nitrite's a polyatomic ion, so this must be ionic because that's the only thing a polyatomic ion would be in. All right, I mean, right? That's what the name says. So I have hydrogen, which is a +1, right? Because ionic bonding needs charges and crisscross. Nitrite, look it up in the list, NO2 with a -1. Now, it's really handy they're both ones, because when I crisscross a 1 and a 1, I don't need to write any of that at all. So I'm going to erase the charges, and I'm actually not going to write the ones. Okay, that's all there is to it. Now I'm going to just pick a different, I thought I was going to pick a different color. There we go. Okay, so, oh, it did say, I should go back to that color. It did say it was aqueous. So I'm going to put a little AQ right there for aqueous, okay? Don't let the phases of matter become a big deal yet. It's not yet a big deal. Later on, that will be something you really need to get used to putting down. I'm just wanting to introduce them now. Okay, solid barium carbonate. So it starts with a metal. So here's my barium metal, and it's a metal, so I better put a charge because I've got to crisscross reduce. Carbonate's a polyatomic ion. CO3, it's -2 according to our chart. Really handy. 2 and 2 crisscross reduce ones. So I'm going to erase the ones, and there we go. All right. And it yields. Oh, yields already. Okay, sure. Why not? We got the arrow. Solid barium oxide. So here's my barium. And now, by the way, if I have to say this, over on the left barium was a +2. It's going to stay the same. Okay, so it's a +2 there. And oxide is oxygen. Go to the periodic table, look it up. Group 6A, those are -2. The nonmetals there are -2. Not the metals, but the nonmetals are -2. And so again, I have a 2-2 combination. And so again, they're going to crisscross reduce to ones. And I don't have to write ones, so I'm not going to write ones. All right. Okay. It says it's a solid. I'm going to put a little S there. By the way, this was a solid. I'm going to put a little S there. Just trying to get you used to it. And here's carbon dioxide. Starts with a nonmetal. I'm going to use the prefixes. Now, how many carbons? And you're like, well, there's no prefix. Well, right, and that's important. What prefix is there when we don't write a prefix? Mono, right? We leave mono off the beginning. So it's 1 carbon and 2 oxygens, and then it's a gas. So there we go. No crisscross, no reduce, because it was covalent. Just use the prefixes. Done. All right. Let's try the next one. Aluminum sulfate. So I have aluminum, and it's a metal. I mean, looking at aluminum foil probably tells you it's a metal, right? Okay, so that's a +3. Sulfate is an SO4. And that, if you look it up in the chart, is a -2. So there we go. So I'm going to crisscross. I can't reduce. I'm going to erase the charges. Okay. Now I want to point out how I'm not told the phase of matter. So what do we do when not told the phase of matter? Excuse me. If we're not told, I don't expect you to know. So we're just not going to worry about it. That easy. Okay. These are just things I wanted to get used to. And you will not always, even if you're used to them, you will not always be told the phase of matter. And I would know from personal experience what aluminum sulfate is because I have seen it and I've carried it around before in my hand because, you know, I have it in the storeroom. But I don't expect you to know. So we're just not going to worry about it. Okay, we've got iron 3 phosphite. So iron is Fe. Now that's a metal. I guess I need to say it. And so metals need the charges. That 3 is then the charge. It's not the amount of irons, it's the charge because I've got to have a charge to crisscross and reduce. Okay. And then phosphite is a PO3, and it's also a -3. So really handy when it's 3 and 3, those reduce to ones, and I don't write ones. So I'm done. All right. So here we go. Yields. Aluminum phosphite. So I have Al with a +3 again, because it was +3 on the left. It's +3 here on the right. Same thing. Okay. It stays the same again. Phosphites, again, a PO3. Well, I don't know why suddenly. Okay, PO3 with a -3. Ooh, 3 and 3 reduce. Okay, so those are ones. And I want a chance to redo that 3. I don't know what happened there. I mean, I know my handwriting's bad, but it's like I can do better. There we go. So AlPO3. There we go. They were both 3s. When I crisscross, I reduce. And iron, still +3. Okay, tells me right there anyway. And sulfate is still SO4 and is still a -2. And I crisscross and reduce this because iron is a metal. So we crisscross and reduce. The 2 goes there. The 3 goes there. Now notice the 3's outside the parentheses because I don't mess with what's in the parentheses. That's untouchable. We're not going to mess with it. So it's got to crisscross to the outside. Okay. So that's that one. That's all there is to it. We crisscrossed actually everything, crisscrossed and reduced, because it was all ionic. So there we go. Okay. Now on this last one, what you'll notice is we're going to go in reverse. I'll use green. Okay. So we had we had names and we were looking for symbols, and that's typical of what we do from lab work. But maybe you have the formula and you're trying to, like, over video tell someone about this lab you do. You're still going to use the words for it to communicate with them out of your mouth. You're not just going to sit there, okay, parenthesis, S, parenthesis. We don't do that. We say things like solid, and K is potassium. And for the plus sign, H2O. Now, you know from earlier, H2O is dihydrogen monoxide. I'm okay if you want to call it water. I would take that. I mean, almost like everyone does. Okay, so there we go, water. Oh, and it was liquid water. So I should have squeezed in a little liquid there. And again, I'm not, okay, I squeezed it in and you can't read my writing. Let me just pause and erase and try again. Okay, liquid water and liquid water. Okay. Yields, because I'm ready for the arrow. KOH. Now I need to know what KOH is. Now it's ionic. It already did a crisscross reduce. I'm just naming it. No prefixes is what I'm trying to point out. So we're just naming. That your naming is really great when it comes to this. Okay. Potassium. Oh, how about I do the phase of matter first? It just kind of sounds better if I do the phase of matter first. Let's do that. And again, I'm not putting much emphasis right now on the phase of matter because it's not super important, but aqueous, potassium, hydroxide, you look up OH and you'll find hydroxide, and then H2 is, there's no other element with it, so it's just hydrogen. And it tells us it's a gas. So there we go, hydrogen gas, done. Okay, so again, we're really just practicing nomenclature. That's what we're doing. We're doing it in a different way, but we're practicing nomenclature, mixing it all up. Let me repeat this one last time, okay? When we do nomenclature, we have 2 types, ionic and covalent. Ionic starts with a metal, crisscross and reduce. Covalent starts with a nonmetal, prefixes. Okay, big, huge difference. Notice prefixes. I am not saying crisscross reduce. There's none of that. It's just prefixes. That's all. Don't make it harder than it is. Don't add steps to it. Prefixes. With metal, you got to do crisscross and reduce. And that might mean looking up Roman numerals for charge. That might mean looking up polyatomic ions for ionic bonding for a charge. Okay, so there's those 2 types. Don't confuse the 2. Be sure you can tell the difference. All right. Rest of the questions here are practice. We had, again, in-class time, but if you're watching this video, you likely missed class. or you're in a situation where you're no longer in class, and so now it is homework. So good luck, but you're not on your own. Come in for tutorials if you need it. That's exactly what tutorial time is designed for.